This is a continuation of solutions to the Trig Test 2 review. Okay, here's 6D. Graph y equals sine of x plus pi over 4. Now, there's nothing in front of the sine, so we have an amplitude of 1. There's no stretching. The amplitude is going to be 1. And the period, notice there's no coefficient of x except 1, so the period is the same as the regular sine function, which will be 2 pi. And then the phase shift, we have x plus pi over 4. So the phase shift, right, basically it's the opposite sign. If this is a plus, it's a shift to the left, this number of spaces. So it's going to be pi over 4 units to the left. So remember, if this is a plus pi over 4, it's going to shift to the left. Here's one way to remember that. How would you get this back to just plain old 0? Well, if you put a negative pi over 4 in for x, all right? So if you put a negative pi over 4 in, you could think of that, that's the negative. You're going to the left. Okay, there's a couple ways to do this. You could graph the sine function, and remember here are the basic in green over here on the left are, the important numbers that you're going to plot, important order pairs you're going to plot on the sine function. And what you could do is then just shift everything pi over 4, or what you could do is make a table for x and y. So I'm going to do x and then the sine of x plus pi over 4. And what happens when you have just a phase shift is all the x values are just shifted pi over 4. So if you take theta over here and you just subtract pi over 4 and you keep the value of the sine the same, watch what happens. Instead of 0, it's negative pi over 4, and then you're going to have to do pi over 2 minus pi over 4. So you're subtracting pi over 4 from each of these x values over here that I've written as theta. So that's going to be pi over 4. And then you're going to do pi minus pi over 4. That's going to give you a 3 pi over 4. And we're going to have 3 pi over 2 minus pi over 4. I think that's, notice these are going up by 2 pi over 4. So that's going to be 5 pi over 4. And the last one, 2 pi minus pi over 4, that's going to be 7 pi over 4. So I've shifted all the x values, right, to the left, and all the y values should stay the same. Oops, this is supposed to be a 0 at the bottom here. Sorry. It's a negative 1. I'm sorry, getting confused here. 0, negative 1, and 0. So if we graph it, this is a little bit trickier. So I've got to start off at negative pi over 4, 0. So let's say this is 2 pi. Okay, so the sine function is going to be shifted. It's going to start here and end right here. Okay, so I'm going to make the extra marks here in between. That makes it a little bit easier. Okay, and the amplitude still 1, so remember you're going to break this up into the 4 pieces. So there's 1, 2, this is halfway in there in the middle, right? And this is going to go up 1, assuming that's the unit of 1. And then in between here, we're going to go down 1, and there's our sine function shifted pi over 4 to the left. Now we could do the same thing over here. It's going to go down, back up. And ending right here to show 2 periods. All right, so there we go. And if you were going to label these, it's kind of hard on this graph, but you could still label. This is pi, etc. right here. And let's see, this is negative pi, and that's negative 2 pi, etc. And there's our graph. And again, you could verify that these are the right order pairs. Negative pi over 4, 0. So you go negative pi over 4, 0. And then you go pi over 4, you're going up 1. 3 pi over 4, you're at 0, etc. So it's always good to verify at the end. All right, so that's the graph of y equals sine of x plus pi over 4.